one of the things we're learning about today is called, is determining whether a function is increasing or decreasing, okay? Increasing means that the y value goes up. Decreasing means that the y value goes down. So if we were to look at this graph, does it have areas that are both decreasing and areas that are increasing? Yeah, okay, so it's decreasing here, and increasing here, and decreasing here, and increasing here, and decreasing there, and increasing there. Does that make sense? Yep. So increasing is going up, and decreasing is going down. Okay, the other thing we're talking about today is minimums and maximums. Generally, the word minimum means the absolute highest that something gets to. No, did I say minimum? Yeah. Okay, sorry. The word minimum generally means the absolute lowest that something gets to, and the word maximum generally means the absolute highest that something gets to. We'll notice these arrows at the end. So what is the absolute highest this graph will get to? Infinity. What is the absolute lowest this graph will get to? -4. Okay. But you know what? Sometimes just knowing the absolute highest and absolute lowest points are not enough. Sometimes we like to know where other minimums and maximums are, okay? So we're actually going to talk today about something called local minimums and local maximums. And those are places where that's not absolutely the highest or lowest points, but it is high and low points in the graph. So this is an absolute minimum, but we would also call that a local minimum because it is where the graph changes direction from decreasing to increasing. So there's a minimum there. And then where the graph changes from increasing to decreasing, there's a maximum, a local maximum. And then where the graph changes from decreasing to increasing, there's a local minimum. And then where the graph changes from increasing to decreasing, there's a local maximum. And there's another local minimum over here. Does that make sense? Yeah. So anytime that graph changes directions, we have minimums and maximums. Okay. The other thing we're going to discuss today is official names for the symmetry that we've learned about previously. Since these are functions now, Chapter 3 is all about functions. Since we're now talking about functions, are they all going to pass the vertical line test? Yeah. If they're functions. Yes, they will. Okay. Does a graph that has x-axis symmetry ever pass the vertical line test? Think about x-axis symmetry. X-axis symmetry would be like, for example, a sideways parabola where you can fold it in half on the x-axis, and if we try and draw vertical lines through it, it's not ever going to be a function, right? So since we're talking about functions in Chapter 3, that means we are now throwing out x-axis symmetry. We don't care about it anymore. All we care about is y-axis symmetry and origin symmetry. And since we're throwing x-axis out, remember how it was either one or none or all? Can we anymore have all? No, because no x-axis. So it's either y-axis symmetry, or it's origin symmetry, or it's none. Those are our only options. And we're going to learn specific names for each one of those. Okay.